Hello, everybody. So we have another question from Arrhenius equations as well, which was asked in the year 2022. So let's start. It's a very good question. So the question goes like this. The effective activation energy for the reaction with the following potential energy versus reaction coordinate plot is. Potential energy versus reaction coordinate plot is. Okay, so this is the plot. And they have also given an equation. In the equation, they have described that the reactants A plus B reversibly form an intermediate with rate constants Ka and K prime. And the intermediate forms product after that with the rate constant of Kb. The corresponding activation energies are depicted. Okay, so what's the question? The effective activation energy for this reaction is the question. Okay, so the 4 options are given. Very easy. So if you have a question of this sort, we'll first write the rate of the reaction. That is going to be the step where the product is being formed. And over here, it is rate is equal to Kb into concentration of I. Now, I being an intermediate, we need to eliminate I from our system. Okay, so we have equilibrium in the system. We can eliminate it with the equilibrium approximation method. How to do that? So with the equilibrium approximation method, we know that the equilibrium constant, what is equilibrium constant? The rate constant for the forward step divided by the rate constant for the backward step. This is going to be equal to concentration of the product of that step is I divided by concentration of the reactants A into B. Now, if I rearrange for I, I'll get concentration of I is equal to Ka by Ka prime into concentration of A into concentration of B. Now, I'll put this expression of I over here. Correct. So if I put that expression of I over there, my rate is going to be equal to Ka, Kb divided by K prime into concentration of A into concentration of B. So now you have got the overall rate expression. Now from this, you can write the overall expression for the rate constant, which is equal to Ka, Kb divided by K prime. It's not K1, it's K prime. Okay. Now, if you have a relation like this among the rate constants, with Arrhenius equation, we already know how to simplify this and write it in terms of the activation energies. Correct? I'll just summarize how is that done. For example, if you have two rate constants like this, K1 into K2. Now I'm explaining this so that you get a better understanding. If you have the overall rate constant as K1 into K2, your overall, let's say this is K overall, your overall activation energy will be equal to, if you have product of the rate constants, it will appear as sum of the activation energies. Okay. Now, if your overall rate constant is K1 divided by K2, your overall activation energy is going to be EA1 minus EA2. So do you understand? If it is divided by, it will appear as minus in the activation energy. If it is multiplication in the rate constants, it will appear as addition in the activation energy. And last one, if you have powers, for example, if you have K1 to the power 1 by 2. And let's say you have into 2K2. In this case, what you have to be careful of is whatever power is there. So now power is only responsible or it is only applicable on K1. The power will be applied as coefficient. The power will be applied as a coefficient, that is 1 by 2 EA1. Multiplication becomes plus. This coefficient will not appear in the activation energy and this simply becomes EA2. So the detailed derivations, etc. are discussed in our classes. Now, to solve this problem, all you need is this much. Okay? So if you know this, you can solve this. Correct? You have got K overall. Now, from the question, if you need the overall activation energy, that is going to be equal to Ka corresponding to Ea plus Kb. It is into Kb over here, so it will appear as plus Eb. Sorry. It is into over here. Multiplications will appear as plus in the activation energies. And then you have divided by. Divided by will appear as minus in the activation energies, Ea prime. Ea plus Eb minus Ea prime, it is option B. Option B is the correct answer. Okay. So this is very important. You get a lot of questions from this. All right. So that's all. Thank you. See you in the next video.